Hello and welcome again to my Physical Science online video lectures and labs supplement series. Today's video is a lab video, and it is going to be another of my lab walkthrough discussion and examples videos. This one we're going to look at the tire pressure lab. So let's pull up our instructions for this lab. You're going to be basically using the tire pressure of your vehicle to get an estimated weight of your vehicle. And so there are actually about three things that you need. You need a tire pressure gauge, you need an automobile, although a motorcycle or a bicycle, etc. will work, and graphing paper. So let's look through a few simple instructions here. Recall that the definition for pressure is force per unit area. So this is a pretty simple, straightforward lab. You basically go through, measure the tire pressure of the 4 tires on your car. Note that you would have to modify this procedure slightly if you are using, say, a pickup truck with the dual wheel in the back. Then you've got to measure 6 pressures because you've got 6 tires. You'd also be modifying it if you're using, say, a bicycle, since you have only 2 tires in that case. In any case, what you do is you measure the pressure for each one of your tires. Then you have to measure the effective area of your tire that's in contact with the road. So you can use a piece of graph paper to estimate this. And basically you're going to trace out the outline of your tire onto the graph paper and try to estimate the area of this region of the graph paper. It's worth noting that your tire actually has treads, so you're going to have to make some estimation here as to how much actually is in contact with the road, because the area of the tread that's actually touching the road is the part that actually matters. And then from there you're going to be multiplying the pressure that you've measured for each tire times the area that you measured for that tire, and then you add all of those up to get the weight of your car. So let's see a simple example of how this works. For my example, I'm going to be using this Ducati 900 Supersport, so a motorcycle, hence 2 wheels. And what I'm going to do is I'll measure how much of the wheel's area is in contact with the ground, and I'll measure the pressure of each of these 2 tires. So I'm obviously not going to be doing that on screen, but let's write down at least those numbers. I basically measured for the front tire that the pressure was approximately 34.2 pounds per square inch, and I got an effective area for that front tire of actually about 5.2 square inches. And then in the rear tire I measured a pressure of about 35.9 psi, and I got an area of approximately 5.3 inches squared. So that basically is what would go in to those first couple of spaces. In other words, I would put P1 equals that 34.2 pounds per square inch. So this would be 31.2. There is no rear driver's side, so basically this would be like 0. The rear driver's side would be that 5.9 psi. These two would effectively be 0 because there is no second or third tire. And then scrolling down for the area, these areas would be 5.2 and 5.3, These two would be 0 and 0 because, again, there are no other tires. So since force is pressure times area, we can find what the total weight is. So let's put that in. Basically, we can write that the weight is P1A1 plus P2A2 plus P3A3, which is 0, and P4A4, also 0 in this case. So the P1, of course, and the A1 in my case is the front tire. P2 and A2 would be the rear tire. So what I need to do here is say that the weight is 34.2 psi is the same as pounds per square inch, so we could represent that as this, and that's times those 5.2 square inches, and then to that we add 35.9 pounds per square inch, and that's of course times 5.3 square inches, and then these other two terms are zeros. So let's pull out our calculator to try and calculate what this is going to give us. So basically the weight here is going to be this times this, so we have 34.2 times 5.2, and so you'll notice by the way that there's per inch here, there's square inches here. Therefore, what we can do is write that the weight is 177.84 pounds plus, now we got to put in the other set, so that's 35.9 times 5.3, and so that's 190.27, so 190.27 pounds. So the total weight is this guy plus this guy, so I need to add to my 190.27 another 177.84, and so that's 368.11 pounds. So we'll write 368.11 pounds. So now I have to go and look up what is the weight of my Ducati. So we go online and we find again the Ducati, and we scroll down, and somewhere in here there's going to be a weight. What's given here is the dry weight and the wet weight. These are both in kilograms. So basically this is going to mean with no fuel, oil, that kind of thing. Here's fuel, oil, etc. And so let's see just how much weight that actually is in pounds. And the way that we can do that is, for example, you can go on to Google if all you have is this in kilograms, and you can actually type convert 180 kilograms to pounds. And here it shows that 180 kilograms is 396.832. So we would write 396.832 pounds. This other one obviously is going to be a little farther off from what I got doing it this way. So let's pull up this thing and change to 192.5, and it should be 424.4 pounds. So 424.4 pounds. So somewhere in that range is what's the expected. Okay, so how much off are we from this range? Well, given that it was near to having an empty tank of gas, given that I don't have anything sitting on it, etc., we're probably going to be closer to the dry weight than the wet weight. So let's go ahead and calculate the percent error for that. And again, you can do that. You can notice that that's the last line here. So how do you get percent error? Well, you basically can use the procedure that I've given previously, which is basically that you use the absolute value of the experiment minus the theory, and then you divide by, depending on what you want to compare. Do you want to compare your theory to your experiment or your experiment to your theory? So if you're going to compare experiment to theory, it's like this. And so in my case, the percent error, we got to multiply by 100% to make it into a percentage. The percent error here is going to be basically 368.1 minus 396.8 divided by 396.8. You take an absolute value for both of these, and what you end up with is that the percent error for this experiment was approximately 7.3% in this case. So 7.3% is my percent error for this experiment. That's pretty good. You want to basically do this so that you have lower than 10% error if you've done a really good job, but measurements are measurements, theory is theory. You may or may not get within that 10%. So that's a basic walkthrough of this entire lab. I hope this is a helpful video, and thanks.